So not Stan Lee, but we'll keep it quick enough so you can make it to Stan's session, which is right after this. It's only like 20 feet away, so we'll make sure you get there in time. So the theme of this week has been connected thinking, and really exciting for us to be here. This is our first full participation in a Samsung developer conference. Joyent is, as of a year ago, part of the Samsung family. We were acquired back in June of 2016, and I mean, based on everything we've heard and what's been going on this week, I mean, there's not been a more exciting time to either be a partner or part of what's happening inside Samsung. So I was going to spend a little bit of time today sharing what we've seen and heard from companies who are beginning to think about what's next for cloud strategy and cloud infrastructure management. How many people in here are using the public cloud today? So it goes without saying that public cloud has become the standard by which applications are deployed, managed, and operated. And companies that were early adopters of cloud are now beginning to ask questions like, well, now that I'm at scale, how do I begin to incorporate additional cloud providers to get back some control, reduce costs, and better manage my overall lifecycle of applications? And we'll touch on a bit of that. Just a quick briefer on Joyent. Another show of hands, who's familiar with Joyent? A lot of people. Okay, great. Great. Half of whom work here. No. So Joyent is a cloud infrastructure company. We've been in the space for a little over 11 years, and we operate public cloud infrastructure across the globe. So similar to AWS or Google, you can deploy your application, pay by the minute, spin up and spin down as you need. We also uniquely take all that software that runs our public cloud, and we make that available for you to deploy in your own data center. So it allows you to run a true public cloud set of software behind the firewall in your own data center. And recently, and working with Samsung, a new offering that we announced was Triton Private Regions. And the Triton Private Region approach is one that really tries to solve for the cost savings and control that people want when they're deploying private, but the flexibility and agility that the public cloud affords to companies. And we'll talk a little bit more about how Samsung is using this offering and how this is part of their multi-cloud strategy here in a minute. So I don't think this question needs a long answer. I mean, what public cloud has done to advance innovation and agility within companies and help get applications to market faster and to scale is why it is the de facto standard now for building and operating applications. But as companies have begun to get to scale in public cloud, there are certain use cases and certain aspects of it that become a bit challenging. The first of those is that you do have to turn over control. And the reason that we've gone to public cloud in the first place is to abstract away and get rid of needing to manage hardware and think about capacity planning and deal with all of the sausage factory that is delivering infrastructure elastically to applications. But as you start to get to scale and you're running online applications that are powering a business, some of the limitations in a true public cloud environment are that you can't reach into those services and those systems when things go wrong. When you have an outage or you have a degradation of performance, you are left with adding more capacity. And that level of control and insight and access and reach is one of the things that the companies that we work with at scale have had a hard time with. The other aspect is cost, especially when you're thinking about predictable use cases and predictable application uses. The rental model is expensive. And the trade-off is that you can spin up 10,000 computers and spin them down in a couple of hours and only pay for those couple of hours. But when you know you're going to run 10,000 computers or petabytes of data, and you're going to do that for years, the rental market is expensive, ours included. Our public cloud is much more expensive than if you were to go run a private cloud yourself. But private cloud has its own set of challenges. You now have to go back into the business of thinking about buying hardware from Dell and leasing data center space and data center management. And yes, you can greatly reduce cost. Yes, you can now start controlling aspects of your business around, regulatory compliance and being able to optimize and understand and reach into systems. But I think the market has spoken. No one wants to make that trade-off and go back private where they have to own and operate everything. And the third in the public cloud space is lock-in. One of the ways that public cloud has been made easy is by taking open source software projects and proprietarizing them and making them services. And that's great, and that has afforded so much velocity in the market by doing that. But again, once companies start to get to scale and are thinking about their 3 and 5 and 10-year investments in their application architecture, that kind of lock-in is a question, is a concern of that trade-off that companies may or may not want to make. So what do you do about it? Start by thinking about the things that you want to own and control better, and things that you want to have a little bit more of a handle on around cost and control. And data has been a place where a lot of the companies that we work with have started. One of the biggest reasons that data has been a starting point for these companies is that it is one of the things that is the least portable. This was a quote from Andy Jassy. If you don't know Andy, he's the CEO of AWS. And he was articulating how difficult it is to move large volumes of data over the internet, even if you have dedicated connectivity. And talking about how it would take you 26 years to move an exabyte of data on a dedicated 10 gig link. Now, many people in this room may not be at exabyte data scale or even 500 petabyte scale. But I think if you look at what we've been talking about yesterday and today, the building block for these data-driven services is data. And companies are ever more increasingly storing everything, keeping everything, and the data storage velocity is really starting to pick up. The end of the story was, this was an announcement ahead of AWS's Snowmobile service, which is a way in which you can have a semi-trailer truck show up at your data center on premise, upload 100 petabytes of data into this tractor trailer, and then they will drive it to Amazon and upload it for you. And that allows you to get an exabyte of data into Amazon in closer to 4 to 6 months. And that's really powerful as companies are in the early adoption stage and needing to get that data to the cloud to use it and build services on top of it. The one problem is there's no such thing as a Snowmobile service out of the cloud. And so when you're talking about a future in which you may want to move your data to a different environment, when you start to get to scale, control and ownership of that data, again, is a challenge that companies are looking at. So what's another reason to start looking at data as one thing that you might carve out from your current public cloud strategy? Well, first, cost control is at the top of the list for a lot of companies. Data storage is a very predictable workload compared to cloud computing. Most companies know they're going to keep and hold data for a long time. And again, taking data out of a rental model and moving it into a lease model is a way in which companies can significantly lower the cost of the services that they're building on top of those data sets. The second is being able to innovate, being able to have control over your data such that as you're building these data-driven services, these services that are the experiences that you are engaging with your customer behind, you're able to customize what that data environment looks like rather than consuming an abstracted service out of the box. And probably one of the other big reasons why considering data as the first place to start for a hybrid or a multi-cloud architecture is that it's a relatively simple first step. If you're operating in Amazon and you've got a very large S3 environment, taking your S3 and unsnapping that and snapping in a, say, managed private region from Triton as the data backend is a very simple step and does not require your developers to be worrying about changing their tool sets and their workflows and the things that they're doing at the application layer. And yet you can achieve control over the most important asset of your business in a significantly lower set of costs. So one example to share, Samsung Cloud. I'm sure everyone is familiar with Samsung Cloud. It is the backup application that runs on your Samsung Galaxy devices and all your Samsung phones. And this backs up everything. And it's been known historically as more of just a backup and restore app, so that when you go and buy a new phone, you can very easily bring over your profile, contacts, calendar, pictures, videos. But with that data store, Samsung is working on more innovative things where you can start collaborating with information. I now can take a picture, it will back up automatically, and I can have that picture shared across device. I can have that picture shared across connections in my contact list with my family. And working on programs that are going to allow for sharing a video and other sorts of innovative things. And so Samsung Cloud, much like many of the enterprises that we work with, were kind of faced with that conundrum. They were large early adopters of one public cloud provider for all the right reasons. And as they got to scale, the cost and that lack of control over that essential data tier became concerning and led them to begin exploring what would a multi-cloud or a hybrid architecture look like, knowing that we refuse to give up the developer innovation and agility that we've gained by going to the public cloud. So the architecture, as I mentioned, was one that would use AWS compute on the front end to do all of the processing and the metadata tasks, and then S3 on the back end for persistent long-term store for all of the data. And again, the question that they were asking is, how can we improve the economics of this such that we can do things like offer more storage to our customers? Apple offers 5 gigs of free storage on their iCloud. S-Cloud now, Samsung Cloud, can offer 15 gigs of free storage and other things they want to go innovate around. But to do that, they need to be able to have an economical storage backend. And so they approached Joyent before the acquisition, and we worked with them on a model by which we could deploy a private object storage cloud region tightly coupled to their application front end running in their public cloud, and do so low latency, do so in a highly secure manner, and allow them to cut nearly 50% out of the cost of their storage backend. And at scale, that is a very, very, very large needle mover in online services. But maybe more importantly than the cost savings was that they now were on a path to independence. They had taken their data out of an outsourced third-party provider and into a private cloud region that, yes, we were running and caretaking for them, but they had the ability to take over control of in a year's or 2 or 3 years' time. And so now they've moved from a rental model into a lease model, but done so in a way that allows for the same low latency and the same application architecture experience that they need to have, so that every time you try and pull a picture up on your phone, it just comes up. And so storage, again, data was a good place for them to start thinking about multi-cloud, thinking about an application architecture that spans beyond one single public cloud provider. And we're seeing maybe many other companies that have data-intensive application architectures following the same model. And so the results for them, again, were just getting back ownership control of the data and saving a good amount of money in the process. So step one is think about your data and how you can gain data independence. Where do you want your data to reside in the following 5 and 10 years? How big is your data going to grow? And what are the benefits of having control over that as you're starting to innovate one layer above your data and write services that are interacting with your customer? This model, by the way, if not made clear on the earlier architecture slide, is one that is multi-cloud. I mean, this is a use a public cloud provider plus Triton private region story, not instead of. I think there's a lot of value in the investment in training and understanding of a public cloud provider that one is using today. And when you're thinking about how I can start to append this in a next generation strategy, this is definitely one in which data is sort of the first place companies are looking. And then the application tier is the next. And thinking about application portability is tough, because when you look at each public cloud service provider today, they all have their own unique set of services. If you're running any sort of upstack services on Amazon versus Google versus Microsoft versus Joyent, you've got different tooling and different capabilities and different services unique to each one. So in our case, where we have really focused and invested is investing in the open source community, because lo and behold, all of these proprietary cloud services that you consume in the public cloud today are open source projects that have become proprietarized, that are open source projects that are now run as services at these public cloud vendors. And our philosophy has been embrace these open source projects, pull in the support of the community, and then start building patterns for automating the operation of these open source projects, making it easy for you to deploy simply a highly available cluster of a relational database and run that with very little operational overhead, and now have the benefit of being able to reach into that and customize and optimize, and when something goes wrong, be able to have a deep look into the subsystem that your application is running on top of. And so we have a program called the Autopilot Pattern Program, which again is a lot of work that we do, a lot of work that the community and our partners do to help automate one who is running upstack services on top of any cloud provider. So this would look like if you're running on AWS today and you're using DynamoDB, we want to make it possible for you to run Cassandra open source in a very reliable and highly operational model, but now have it be completely portable, where you could run that on Amazon, on Google, on Microsoft, on Joyent, and now start to free yourself from the proprietary nature of those embedded services that each cloud provider has. And in that way, it starts to give companies a path, maybe not even to migrate the application tier, to stay with the cloud provider that they're on today, but simply to shift those from proprietary embedded services to open source automated services that are either being run by the customer themselves or run in a services manner by a company like Joyent or other. Two examples I wanted to highlight on these open source services. One is an API Express Gateway project that we've been working on. Most all mobile developers are familiar with and use API gateways, and you will find that in that space there are oftentimes proprietary options when you're using an embedded service from a cloud provider. This is an example of an open project that allows for you to get a lot of the features that you want out of your API gateway, but be able to customize and optimize that experience for your application, rather than have to take what comes out of the box at a particular provider. And the second is how you can start doing function-based computing or serverless on Triton, but being able to do it in the open in a very portable and transferable way, rather than the proprietary nature of function-based computing in cloud providers today. So my colleague Shubra is going to be doing a talk at 2:30 on this and going in, doing a demo of serverless IoT, using this open source framework and open source tools that you could run on Triton, and we've sort of optimized it to be a great solution on Triton. But again, it can run anywhere. And so that is kind of the core two principles that I wanted to highlight today is as you're thinking about moving past one public cloud provider, first be thinking about how you can free your data tier, if it makes sense, and steps you can take to get independence around the data tier. And then secondly, where it makes sense, can you start to convert proprietary per cloud upstack services to open source services that allow you to have portability in the next couple of years of your cloud strategy? Here are the details around the talk at 2:30. And please fill out a feedback session card on this particular talk. I think we have 1 minute.
Yep.
Quick minute for questions.
Yeah,
I tried to speed through that.
Mm-hmm.
Any questions? All right, well, if anyone has any follow-up questions, the Joyent booth is right over there, and very much appreciate your time today. Thank you.
All right, let's give it up for Steve.